Ding dong YouTube, welcome back to the channel. I'm the Jobless Coder, and today I'm going to show you how to create a visualized sound graph in 100 lines of code or less that looks something like this. Alright, so for this I'm using software called Processing 3, which we're going to program in Java. So the first thing that we're going to need to do to get this program to work is to get the music playing. And you'll notice in this folder called test, I have this other folder called data, and I have a bunch of music in here that I've already put in. You can create this folder on your own and add whatever music library or MP3 file you want. In order to get music to successfully play in processing, you're going to need the addition of a library. In order to do that, we'll go to Tools and we'll go to Add Tools. Over here, under Libraries, you'll notice that there is a list of different tools that you can add to your program. And we're going to want to filter under Sound. Under Sound, you'll notice this library here called minim, M-I-N-I-M. You're going to want to click on this and click on Install. I've already gone and done that. We now have everything we need to create our program. So I'm going to want to start by typing import, and then I'm going to want to type ddf.minim.star. And this is going to import the minim library that allows us to control sound. Now I'll go ahead and create a program where the sound will play. Alright, now you'll notice that we've made a size 1280 by 720 window, and we've colored it black and the background 0 in the draw function. Here we've set up our minim, we've loaded it using this, and then in the player we load the file in the data folder called codingtrack2.mp3. And you'll notice over here in the data file there will be a file called codingtrack-02. So if we go ahead and we run this, this is what we get. The music is playing successfully, so we got that part set up. So the next thing we're going to need to do is create a dynamic map of the bars that you see at the beginning of the video, and it's going to need to be a Boolean map to determine whether or not the bars are on or off. The other thing is we need to make it dynamic. We want to be able to change the look of this program, so the integer values for the number of bars across and the bars high need to be variables. Alright, now you'll see I've defined the number of bars, which will be the bars across. The width of the screen is 8, and the bar's height represents the number of bars high. So there's 8 bars by 20 bars across the screen. And what happens is the Boolean map is automatically defaulted to 0. So to test this, we're going to have to take the entire thing and say if it's 0, draw the bar. Now the other thing I've done is taken the stroke value here. Now this is going to divide the area into a grid, and then we're going to color in the grid, but you're not going to be able to see the black on the background unless there is a stroke value for the black as well. This value needs to be set dynamically based on the number of bars wide and the number of bars high. You'll see that the H and the W value, height and the width of each individual bar, and so the stroke is going to have to be set dynamically. In order to do that, I'm taking the minimum value of an equation based on the bar's height and the bar's width. The reason for the minimum value is because if there's a lot of bars really high and they're very thin, then if there's a few that are just going across the width, the stroke will be very high. It'll be a high value of the border around the bar. And what will happen is it will black out the entire screen. You won't see the bar because the width of the stroke will be more than the height of the bar. So you need to take the minimum value. If there's also a lot of bars that are very narrow, but there's maybe 2 or 3 that are high, then it'll also be a high value and it'll block out the bars. So these equations, if you're wondering how I got them, I did a lot of experimenting with different values, the number of bars wide, the number of bars high, and I took the best stroke value for each and I put that in an Excel spreadsheet. And then I just took the lines for the graph that I created and took the equations for those lines. So now when we run the program, this is the result we get. So you can see here that I'm setting the stroke color to black. That's going to determine the border around each of the bars, and the stroke weight is set to that equation that I listed before. I've got a double for loop here to go through the entire map. The first thing I do is I set the fill color. Notice it's red, green, and then blue. Blue is set to 0. The red and the green is determined where exactly the bar is in the scale upwards. So the bars closer to the bottom, they're going to be further down on the J number for the second for loop, on the bar number, and then the bars closer to the top, we want to have a higher number of red. So this is the equation that will determine that. Below that, I have an if statement that says if the map is not set, which the map is default set to false, draw a rectangle, and the width of the bar and the height of the bar are the next values set. We're going to have to make a few changes to this now. I'll go over here and I'll set this to be true. So now every value in the map, if the bar is going to be turned on, we want to turn it to true. And you'll also notice in the example that I showed you that I had an additional bar that was missing. So the 2 bars on the farthest right are going to be the ones that are initially set to the amplitude of the sound. And then the next bars, the next set of bars, are going to transition that as the music is moving. And so I want to set the 3rd bar from the right to be false regardless, because I don't want to draw that bar. So I'm going to basically say that if I is not equal to, and then we're going to go bars minus 3. And this is going to say the first bar over, and then the second bar over. The 3rd bar over, we're not going to draw. The next thing that needs to be done is every single frame, we need to reset the 2 right bars. So we're going to set the amplitude, and then we're going to transition that bar to the left, and then we're going to reset those bars. So over here, I'm going to need to say map at position bars minus 1. And I'm going to need to make this a new Boolean array with the height, bars height. And so I want to do this for the farthest right bar, and then I want to do it again for the second furthest right bar. You can change this in your program if you want. You can just do the furthest right bar, and then instead of setting the 3rd bar to black, you would set the 2nd. You would change that 3 on the bottom to a 2. Alright, so there's a lot to unpack as to what's going on here. So to start, if you notice, I have this float amplitude. The amplitude is going to be determined by taking the left and the right channels, those are the levels of the music, and adding them together and taking the difference of 2. This is going to be a number between 0 and 1. The next thing I'm doing, you'll notice in this for loop here, I'm having this integer p set to the bar's height minus 1, because the bars start on the top and they go to the bottom. So the bar's height minus 1 is going to take the lowest level of the bar, which in this case is the bottom bar. And we're going to count upwards as we go through the for loop, doing a reverse for loop here. So we need to determine whether or not for each bar it is going to be on or off. And the way that we do this is I have this equation down here. And it basically says take the bar's height minus the amplitude divided by the bar's height. So if the amplitude is set to 1, which would be all of the bars, and you divide it by the bar's height, you take 1 divided by 20, the number of bars high, and you determine what the amplitude would have to be incrementally for each bar to turn it on. The reason I have the max amplitude value in here, which at the top I've set to 0.7, is because you're going to have to modify this for every song you do. Not every song you have is going to have a max amplitude of 1. Maybe the song only gets to 50 or 60% volume. So by setting it to 7, this means that when the song is at a lower rate, only half volume, the bar will be at full size. So the lower the max amplitude is, the easier it will be for the bar to go red. Visually, it looks a lot better this way. So what I'm doing is I'm taking that into consideration, and then what I'm saying is I'm saying if it's less than 0, so I'm taking the difference between the bar's height, and if it's less than 0, which means that the amplitude is greater than what the bar requirement is, which is going to ensure that if the amplitude is above the value that you want, the max amplitude, if it goes above that, you're not going to break the for loop by getting a negative number. Here you have the map at the farthest right column is set to the map at the second farthest right column, and we're turning that to true. And we're basically just saying turn this bar on for both the left and the right column based on the amplitude. If what I've written in this for loop confuses you, don't worry, I'm going to include a link in the description of this video to a GitHub repository where you can download this project and actually look at the code that I've written more in depth to try to reverse engineer what I've done. The next thing that needs to be considered is that when we start filling up the graph with all of the color and all of the bars, we're going to be running multiple for loops per frame. Where you have 20 bars high and say 10 bars across, you have 200 bars. So you're going to be running a 200 for loop every single time the frame changes. This is going to slow down your processing quite a lot. So in order to ensure that the processing power of the computer is not overused by this program, we can actually set a frame rate counter to count every single frame, and we can say sample only 2 frames. So every 2 frames of the song it will sample, or you can say 3 or 4. And so the granularity of the bars on the right are going to be less. They're not going to change as readily with the actual beats to the music, but it's going to look a lot better because it's not going to be dragged down or slowed down by freezing frames with the processor. So you'll see here that I have an if statement that says if the frame number, take the mod of the sample rate is equal to 0, then you do everything that's in the draw function. Otherwise, just skip over it. Every single time we're going to call a frame increase at the bottom here. And so with the frames starting out inside the setup, we start the frames at 0 and then they count up. You start the sample rate at 10. The reason I made it 10 is because it's going to be a very noticeable change when I run the program, so you can see exactly what it is that we've done. So you'll see there was a lot of notes and beats that were being skipped over because the sample rate is high. So if I set the sample rate back to 1, every single note, every single beat will be met, but it'll slow down the processor when we start counting the bars across. And this is also going to depend on how many bars you have high, how many bars you have across, and the processor of your own computer. So you're going to have to play with these numbers individually to find out what the best setup is for you. So now the final thing is to take every single bar to the right and set the bar to the left of it to that value. So that way you transition the entire map to the left. So you can see in the outer for loop, I'm starting at the far left side, and then I'm going to bars -2, which is that second bar in from the right. And then in the bottom for loop, I'm saying for the bar's height. So for every single bar, take the entire height, which is y. That's going to be the same across. And then the z is just going to copy the value to the bar on the right and move it over. And this is what's going to happen, is it's going to move all of the bars consistently to the left. So the last thing I'm going to do here is I'm just going to go up to the setup here, and I'm just going to make this comment here, which is going to allow you to change between full screen or windowed view. So here you can just comment out the window, and this will give you the full screen view of that visualized graph. And that's it. That's how you build this visualized sound graph. If you like this video, feel free to leave a comment in the section below, or feel free to subscribe to the channel for any future videos like this. This program was built in just 69 lines of code.